In the previous lecture, I noted that John B. Watson's behaviorism succeeded chiefly at the level of polemic, and that indeed you could not develop a behavioral science of the required sort using no more than Pavlovian conditioning techniques. The greatest behaviorist in the history of the movement surely was B.F. Skinner, who died in 1990 and who spent most of his academic life at Harvard with a hiatus at the University of Minnesota during the 1940s. Skinner started out in life wanting to be a writer in much the same way that William James started out wanting to be a painter. And I gather that William James was never quite satisfied that his talents were up to the task in painting, and Skinner would tell us years later that he wasn't quite sure he'd ever be able to earn a living as a writer. Well, fortunately for psychology, if not for literature, he decided to go into psychology. He was a student of the philosophy of science as well as the basic sciences, and we know that he was considerably influenced by the writings of Ernst Mach. And I shan't spend much time on Mach. He was one of the great physicists of the second half of the 19th century, University of Vienna. You know, when airplanes fly at multiples of the speed of sound, they fly at Mach numbers. Well, that's the same Ernst Mach. But Mach, in addition to being an accomplished physicist, wrote influentially in philosophy of science, and it was part of Mach's program, and in this he was joined by any number of important figures in the community of science. It was very much part of Mach's program to get philosophy and metaphysics out of science. Science, on Mach's account, concerns itself with the observable world and with a systematic treatment of what is observed in the external world. In fact, famously, when addressing the question of what a scientific law is, Mach would write that a law is but a systematic description of experience. So for Mach, the grounding of every science is at the level of observation and measurement. This, of course, mightily influenced not only B.F. Skinner, but an entire generation of scientists early in the 20th century. Skinner was committed to what he repeatedly referred to as a descriptive science of behavior. That is, a non-theoretical science of behavior, something much more akin to a form of engineering than to a form of theoretical physics. How to build behavior into a system and how to be able to predict and control that behavior once you get it in there. The first development of Skinner's thought to reach the public was in a 1938 book called Behavior of Organisms. It became something of a Bible for generations of behaviorists who would refer to it as the B of O, and of course the enemies of behaviorism would often refer to it as just BO. But Behavior of Organisms was at once a method of investigation, an argument for what the subject matter of psychology should be, a statement as to what constitutes reliable data within a field like psychology, and perhaps most important of all, in the final couple of chapters, something of a declaration of independence. That is, a declaration to the effect that a scientific psychology based on observable behavior does not have to tie itself to physiology or chemistry or any other subject. It can prosecute its own agenda, thank you very much, and it can do so with tools ready to hand. So this was a rallying cry for any number of psychologists at the time. Psychology, even before Wundt, was always seeking scientific status and always seeking to define itself in ways that would allow one to distinguish between it and medicine, it and physiology, it and ethology. And here comes Skinner's Behavior of Organisms, and it's just up to the task. Now, what about this dependence, this historic dependence between psychology and physiology? Recall that Wundt wrote a physiological psychology. Throughout the 19th century, the people we would identify as influential in the history of psychology were inevitably tying psychological processes to brain processes, very much as is done today, such that a developed and scientific psychology would essentially be a kind of functional neuroanatomy, how different events in different places in the brain give rise to thoughts or dreams or emotions or associations, learning, memory, and the like. Now, when Skinner gets to this very question, what is the nature of the relationship between a scientific psychology and physiology, he says, well, perhaps none. In any case, it isn't something a psychologist has to worry about. The facts of behavior will survive any theoretical construction we impose on them. He says, from the perspective of a behavioral scientist who has studied the conditions that establish behavior and maintain behavior, and these are conditions in the environment, from the perspective of a behavioral scientist, if you then were to open the zipper of the animal and look inside and find that there was nothing inside at all, you would still have the facts of behavior. Do you see? You would still know the relationship between events in the environment and systematic alterations in the behavior of organisms. Nothing is added to that information by finding out that there are nerves and blood vessels and the like, and nothing would detract from those findings just in case, improbably, and to our great surprise, there wasn't anything inside at all. This came to be known then, this species of behaviorism came to be known in both a positive and a negative connotation as the psychology, quote, of the empty organism. You'll sometimes hear behaviorism referred to as the psychology of the empty organism. That is not something that would have troubled Skinner or any of his students and disciples, whatever. Of course, from the point of view of a descriptive science of behavior, you have every right to assume that the organism is empty. What's added by discovering that the organism is full or filled out? So here was the Declaration of Independence. This is not to say that psychologists have no business being interested in physiology, but it certainly is to say that you can develop a scientific behaviorism without waiting for the physiologists to solve their problems. You don't have to wait until we know everything about the brain in order to figure out just what it is that determines the course of behavior. That's a separate subject, amenable to experimental investigation, and something that can be conducted by psychologists without their looking over their shoulder to see what the people with the electrodes and scalpels are doing. Now, a purely descriptive science of behavior is a science of behavior that has to be extremely lean in its terminology. It can't make use of theory terms as if they had some actual ontological standing. So problems of definition have to be solved for this discipline to get going. What has to be avoided are mentalistic terms. What must be avoided are those terms that presuppose an independent private mental life that only the introspecting subject has access to and which you only find out about because that subject tells you. This is what has to be shunned. And to shun this, one adopts what are sometimes called operational definitions. That is, you define your chief terms by reference to the actual operations or methods you would use to realize or produce whatever it is that term is referring to. Now let's take a motivational term, hunger. In casual discourse, the way you explain why an animal or anybody else is going over to the counter and ordering up something and scruffing it down is, oh well, they must be hungry. Now, of course, when you say they must be hungry, you're referring to some internal state, something that only they could know about for sure. It's quite private. You can't see hunger or anything about it, and this then turns out to be some sort of a theory term. It's a kind of murky, mentalistic term. Well, suppose you do want to study the relationship between consummatory behavior like eating or drinking and what? Hunger? No. You're going to study this in relation to some other observable. What would the other observable be? By hunger, I mean hours of food deprivation. Now, the interesting thing about defining hunger that way, or even eliminating the term entirely, is from laboratory to laboratory, nation to nation, year to year, hours of food deprivation are hours of food deprivation. Whether the animal is in Vladivostok or Philadelphia, 30 hours of food deprivation is 30 hours of food deprivation. You don't have to ask whether the animals are now equally hungry. If you wanted to know whether animals were equally anything, you would look for an equality in their behavior. Again, it's all out there, not inside. Skinner would constantly emphasize the claim and try to turn it into a fact, and often with great success, that the determinants of behavior are to be found outside the organism, not inside the organism. Behavior is a response to events in the environment. What an organism has to do is survive in a real physical world. It does this by behaving in response to the challenges presented by that world. A descriptive science of behavior doesn't have to address itself to what's going on inside while all this is going on. It simply has to record with accuracy and precision the relationship between the environment and the behavior that is engaged by that environment. Operational definitions are helpful in that they allow you to establish comparable laboratory procedures from one laboratory to another, and they also allow you to understand the meaning of terms as these are used by different investigators. So as long as investigators are reporting that animals have been kept away from food or drink for 24 hours or 48 hours, we don't have to raise questions about how hungry does a mouse get after 6 o'clock at night, or how much relief is there in that hunger when the mouse has breakfast, etc., etc., etc. Operational definitions. Now, of course, some of this would take on ludicrous proportions. I mean, you really did have to be won over to the ism to stay with this all the way. There were studies in the 1950s of the emotion of love, in which love was defined as the total number of hours out of a given 24-hour period that one was physically proximate to the object of love. And of course, critics would point out that that can only mean that prisoners and guards are desperately in love with each other because they're constantly in each other's company. Not to mention the fact that one very often finds oneself associating with others in a purely habitual way. Everyone, I should think, hearing this lecture would agree that if the question is a question about the authenticity and intensity and abiding nature of love, that any attempt to establish this by taking out a watch is likely to disappoint all concerned, and indeed probably offend at least one of them. Nonetheless, a descriptive science is a descriptive science. You don't use terms that resist description at the level of public observation. That's how it goes. Now, in 1938, I don't think the world was quite ready for Skinnerian behaviorism. In fact, the book almost went out of print. We find Skinner's influence picking up in 1950. In fact, the influence of Skinnerian behaviorism picks up chiefly as a result of a book written by Fred Keller and W.N. Schoenfeld, a Principles of Psychology book. The two of them were professors at Columbia University. Fred Keller had been B.F. Skinner's roommate and one of Skinner's closest friends over the course of both of their very, very long lifetimes. Fred Keller died, I think, in 1993 or 4. B.F. Skinner died in 1990. In Skinner's autobiography, his 3-volume autobiography, Fred Keller is cited often. Well, Keller and Schoenfeld decided, both of them committed behaviorists, decided that the way to put behaviorism on the map is to arrange an entire psychology curriculum around principles of behavior, around behavioristic psychology. And so what they did at Columbia in this book and in the curriculum was feature the usual courses in psychology on perception and emotion and learning and memory, but all of it cast in behavioristic terms. And all of these terms operationally defined and translatable into actual laboratory manipulations. Now, I don't want to say that Keller and Schoenfeld's book created or whetted appetites for behaviorism. What I do want to say is this: it's an interesting piece of intellectual history. 1938 comes along. Skinner serves up a book that, in most of its major projections, does everything the Keller and Schoenfeld book does. No takers. 1950, Keller and Schoenfeld put together this program at Columbia and a book that goes with it, and we now find copies of Skinner's Behavior of Organisms increasing in popularity and found here and there and used in courses, and all the books that Skinner will write thereafter gobbled up almost immediately. So the Trivial Pursuits question is, can anyone think of something that might have happened between 1938, say, and 1950 that might have something to do with this popularity? Well, I might mention in passing that there was one little historical event that took place during that interval. I believe it's called World War II. Now, why would World War II have much to do with this? Well, the right side, the virtuous side in World War II, the Allied powers, as we say, stood for an egalitarian, democratic form of life, Everybody gets a turn at the bat. Nobody is any better than anybody else. If you set the conditions up right, give everybody an equal start, they will make something of their lives. And who are we fighting? We're fighting the blue meanies who have attached themselves to nativistic, instinctual theories of types. The whole thing is predetermined. We want pure Aryan characters going around. Everyone should be blonde and blue-eyed, etc., etc., etc. The tension seemed very much to be a tension between that radically environmentalistic, hopeful, progressive, yes, American way of doing things. I'm mimicking some of the propaganda of the period, which was effective to the extent that it also reached certain deep truths at the same time. A progressive, optimistic, environmentalistic, hopeful, the world is our oyster. If you get the manipulations right, you can engineer the kind of society that anybody would want to live in, versus this ancient, gray, gluing, preformistic, deterministic, typological psychology. There are these types and those types, and never the twain shall meet. Well, I should say that thanks in part to Nazi propaganda, by 1945, no one was in the mood for instinct theories of psychology or genetic theories of psychology. The right psychology is the right-minded psychology, and that is an environmentalistic and optimistic psychology, not tied to ancient theories and ancient prejudices. I don't want to harp on this. I simply want to note that major developments in the sciences, taking psychology to be one of the sciences, but in physics and chemistry and biology, cannot be understood entirely independently of the larger cultural and social forces operating at a given time, whether it's Copernicanism or the Ptolemaic view of the universe or Newtonianism or the witch hunts or genetic psychology, yay or nay. It is the culture that finally decides what it will focus on, what it will approve of, what it will seek to limit. And behaviorism came along at the right time, certainly in our own national history, with the right kind of message. Skynner and his version of behaviorism surely were beneficiaries of that otherwise macabre and destructive event. Well, what's involved in Skinner's behaviorism? First off, picking up with studies that had been done at the very end of the 19th century by Thorndike, studies of cats inside cages with little loops hanging down. If the cat puts a paw through the loop and pulls on it, the cage opens up and the cat can run out and get a piece of fish. And from studies of this kind, Thorndike was able to publish the first animal learning curves. He plots the amount of time it takes the cat to get out of the cage as a function of the number of trials, presents all this in a book called Animal Intelligence, which came out in 1898, and argues that this is a model of all behavior. Behavior is determined by its consequences. That behavior which gives rise, this is Thorndike's language now, highly mentalistic language, that behavior which gives rise to a satisfying state of affairs tends to be repeated. That behavior that gives rise to an unpleasant or painful state of affairs tends never to be repeated, and he refers to this as a law that covers all behavior, and he calls it the law of effect. Behavior is determined by its effects, do you see? Well, this was all quite interesting. Skynner says, Thorndike had the right idea in that he was looking at the right kind of behavior. He was looking at the behavior an animal uses to get through the world and to secure what's necessary for survival. That's what psychology should be studying. Not the Pavlovian kind, not with a dog locked in a frame, powdered food in the mouth, and saliva measured. What does this represent, do you see? This has nothing to do with that lush Darwinian context in which creatures have to adapt themselves to the demand characteristics of the situation. No. In that latter realm, the behavior that counts is musculoskeletal behavior, so the behavior mediated by the striate muscles, the moving, the grasping, the running, the reaching, do you see? So Thorndike got the right kind of behavior. Problem, of course, is the laboratory setup is weird. You know, anyone who's spent time in the company of cats knows that Thorndike probably picked the wrong species, and he certainly picked a hopeless form of behavior. You could have kept a cat, some cats our dear Phoebe for many, many years, I can assure you. You could keep her away from food for 48 hours, put her in a box with a fish outside. She would size up, I should think, what you expected her to do, and she would proceed to nap. So, and then you've also got Thorndike running around the room trying to catch the cat and like. Skinner doesn't want any of that. What he develops for his own PhD dissertation, and then refines over a course of years, is the now famous Skinner box. First thing you want to do is limit behavior. So put the animal in an enclosure that is relatively confining. You also want to limit responses to those that are readily measured and quantified. So you've got a little lever now sticking out inside of the box, and there's the rat in the box. The animal of choice is the white rat. I should point out that you only find this animal in psychology laboratory. The behaviorism gave us the fullest description of the behavior of an organism you're likely to find only in behavioral psychology departments. But that's a story for another day. And of course, what a rat does inside a box is generally not what rats are doing at wharfs, running up ropes, etc. But I say that really is another matter. All right, there's the rat inside the box, has been deprived of food. Now, what do you see the rat doing? Well, sort of sniffs around the inside of the box, obviously trying to get out and like, and here's this lever sticking out. Now, the animal may lean on it for balance or might sit on it. And microswitch is closed, a little food magazine tray is turned, and a pellet of food drops down into a little food well just underneath the lever. Animal does some sort of a double take, goes over to the food well, lifts up the pellet, eats it. And now you'll notice right away that there's a little less time spent sniffing around the top corners of the cage and rather more time spent around that funny thing sticking out of there. Generally within an hour, you will have an animal pressing the bar, in fact, even leaning back on the haunches and pressing away. Now, this is the result of what Skinner calls continuous reinforcement. That's where every bar press results in a reinforcer. How about an operational definition of a reinforcer? Do we want to use that tired old language, that mentalistic language of Thorndike, that something is reinforcing because it gives rise to a pleasurable state of affairs? Does anybody know whether a rat eating a pellet of food is in a pleasurable state of affairs? No. Skinner says, here's an operational definition of a reinforcer. A stimulus is a reinforcer when it alters the probability of the behavior that produces it. Any stimulus that significantly increases the likelihood of the behavior that brings it about is a positive reinforcer. And any behavior that significantly lowers the likelihood of the behavior that brings it about is a negative reinforcer. So it's the animal's behavior that defines the reinforcer. It's not a psychologist trying to get into the mind of rodents. It's the behavior itself that determines whether something is rewarding or non-rewarding. Better, reinforcing or not reinforcing. Well, when Skinner was out at Minnesota and there was a war on and you couldn't get government grants to play around with rats and pigeons and the like, he was working with pigeons. He tells us that they do eat very nearly their own weight in food. Young psychologists can go broke trying to do studies like this. So instead of delivering a reinforcer per peck, Skinner arranged to deliver a reinforcer for every other peck. This would cut down the food costs by 50%. Of course, what you discover when you do this is that the bird goes over to the key and now goes. Well, now you arrange the equipment so that you get a grain of food for every 3 pecks. Now, this is an example of what's called partial reinforcement. Not every response is reinforced, but only some fraction of the responses. And generically, these are referred to as schedules of reinforcement. This schedule of reinforcement would be designated FR3, a fixed ratio 3, which is to say you get a reinforcer per 3 responses. You now, over a series of sessions, can stretch this out to, you could have an FR20, an FR50. In fact, you can add in a fixed interval schedule. So you not only have to get responses like that, but within a particular window of time. And Skinner was able to show that you can jack up response rates to unbelievable levels. In fact, He had one pigeon whose pecking rate was made so fast that the bill actually started to burn up. You'd see smoke coming from the pigeon's bill. The most interesting of the schedules of reinforcement turns out to be the variable ratio schedule, and this will repay close attention. Here's the situation. The animal has started out on continuous reinforcement over 2, 3, 4, 5 training sessions. Every response receives a pellet. You now build in a fixed ratio schedule with a low FR value, FR2, FR3. You have a couple of sessions like that, and you start stretching out the FR requirement so that the animal might have to emit 15, 20 responses. You now move to what is a low variable ratio schedule. Now, what that means is this. Let's say you move to a VR2. That means over a long, long run of trials, every second response would receive a reinforcer. But you never know trial to trial which response will. Do you see? That's determined randomly. You now stretch out the VR2 to a VR5, a VR10, a VR20. Guess what happens? Virtually for the rest of that animal's life, you can disconnect the feeder, put that animal in the test chamber, and it will press the bar ad infinitum. Skinner refers to behavior shaped that way, you'll be interested in this, as gambling behavior. He has a funny essay in which he talks about blue-haired ladies at slot machines in Las Vegas. Well, what he wants to say about variable ratio reinforcement is this. That's the sort of schedule that will maintain stable rates of behavior indefinitely. Since to use a mentalistic or introspective kind of language, which a behaviorist would condemn, we can say this. How does the animal, or somebody at a slot machine, know when to stop pulling the lever? The answer is never. Do you see, it may pay off next time, next time, next time, because nothing in the acquisition of the behavior provides a cue as to what condition must be satisfied for a reinforcer to be delivered. If you take fixed ratio reinforcement, you know this. Every 3 gets it. All right, well, now we disconnect the feeder, and I go, whoops, nothing happened. Nothing happened. Oh, well, I guess the game is over. But suppose this has now been converted into behavior shaped by variable ratio reinforcement. Well, there's no telling what the contingency is that must be met in order for a reward to be given. This is one of the most powerful displays, I think, that behavioristic psychology was able to produce. The ability to maintain behavior over long stretches of time in an animal that's virtually indefatigable in responding, notwithstanding the fact that a reinforcer has not been delivered for days or weeks or even months. This is a powerful illustration of how events in the environment can impose extraordinary reliability on the behavior of organisms. Similarly, avoidance conditioning. Here's the paradigm. Animal is put in a box, it has an electrified floor, a light comes on, and 10 seconds after the light goes off, the floor is electrified. There's a little barrier that the animal can jump over and thereby get away from the shock. 1 or 2 trials, 1 or 2 of these trials, maybe 3 of these trials. You put the animal in the box and turn the light on, and he jumps over the barrier. Put him back in the box, turn the light on, he jumps over the barrier, and jumps over the barrier, and will jump over the barrier till the day he dies. Notwithstanding the fact that there have only been 2, maybe there was only 1 punishing stimulus. Now again, let's anthropomorphize for a minute. What might the rat be saying? The rat stands on the floor, a light comes on, and 15 or 20 milliamps comes up through the paws, and he's half a foot off the ground. Next time the light comes on, do you sit there and say, gee, I wonder if the shock is going to come this time? No, no, no. You run. And you keep doing it. Again, a very powerful illustration of how an event in the environment can get a controlling hold on behavior indefinitely. There are parents who can't figure out why an offspring ran away. Is there any physical abuse in this family? No. Do you use corporal punishment? No. Did you ever hit Bill? Oh, look, we had an argument once. Yeah, I belted him, but it's the only time. Do you see? This is the classic example of avoidance conditioning. You don't have to do it more than once in order for the organism to behave in such a way as to avoid that environment. Let's keep these things in mind.